whatever it'll take to get to 100% renewables, and what's the missing piece.
You can be ideologically sound and morally correct and sustainable and still actually make money, but a lot of people think that's not the case.
Treecoin's about democratizing and decentralizing the carbon market. Treecoin is this end-to-end platform where you can create the tokens from a forest, just reforestation being a lucrative pathway.
Yeah, not only the right thing to do, but the right thing to do financially.
Yeah, and when those two things come together, then you do see mass uptake.
We've just been sitting down with Demian Natakhan, director of Enhar and founder of Treecoin, and he just so happens to have been my wind lecturer nearly 20 years ago. We cover quite a bit in this podcast, in no particular order: Scottish wind turbines, large battery storage systems, Treecoin, carbon accounting, and a whole lot more. So if you like your discussions nitty-gritty, battery storage, sustainability, renewable energy, then strap yourself in, sit right down and allow yourself to be treated to this particular podcast. It was a lot of fun. So I wanted to start off really talking about at the beginning, but not obviously when you were born, but growing up.
Yeah.
You're obviously from England.
Scotland.
Well, there you go. I got it wrong.
I don't have the accent strong, but I'm from Edinburgh originally.
From Edinburgh. Yeah, but you would have come out when you were...
20 years ago I came to Australia.
Right. Yeah. And isn't it the case that if you come out to another country after you're about 16 or 17, unless you're fully immersed, you've always got a little bit of an accent?
Yeah, well, I've definitely kept my UK accent. I've got a sort of broad UK accent. My parents are from different spots around. We all moved to Scotland when I was a little boy. Yeah. But yeah, I went to school there, and one day at school we got offered to do anything as a project, just whatever caught your interest. I was there at the Steiner School, and it's a class 8, 14 years old. And so I thought, what do I want to do? And I thought of a solar-powered car would be pretty interesting, and then I ended up making a solar-powered water heater, like parabolic trough with a mirror. And back in the back garden of this apartment in Scotland, we got it.
There wouldn't have been much sun there though in Scotland.
Got a sunny day. Picked one of the rare ones, and then it boiled the water in the tube, and that was me sort of hooked, because I just thought, well, this is really fun, making technology that is like directly linking natural sources of energy to useful output, and then as a tangent to that, I got learning about this thing called climate change and why it was part of this bigger picture solution. And
Hang on, this is in primary school?
Yeah, 14 years old.
What?
Yeah.
Oh, okay, so high school.
Yeah, just at the start.
Yeah, right.
Yeah.
So and you said, sorry, I got to interrupt because you said Steiner.
Yeah.
So we're talking about Rudolf Steiner.
That's right, yeah.
The, I can never pronounce.
Anthroposophical. Yeah.
That was the best I've ever heard anyone say that. Yeah, biodynamics, which I'm personally interested in. So Steiner has a school. It's slightly different from Montessori, but it's along the lines of allowing the child to learn naturally. Is that right?
Yeah, there is a curriculum. It's a very structured and detailed curriculum for all 12 years, but within that there's a lot of creativity encouraged. So this was an example, like a blank canvas opportunity for students to follow any interest path they wanted to for a sort of 1 month block or something, and spend quite a bit of time exploring what inspired me personally, and that was different to everyone else in my class. So that's a kind of core part of the Steiner approach, is that each person's got their own unique path ahead of them in life. It's no one's a cookie cutter, really. So that was a good thing I enjoyed about the school, while it had limited size and capacity and resources from a kind of I guess a scale point of view compared to other larger state schools around the place. What it made up for with that was this sort of personal attention to whatever the individual was really inspired by, and that's probably I benefited from that. I think others. I'm a big fan, And when later in life, my father said, "Oh, I'm glad you could use computer, because I wasn't sure if you'd get that sort of technical education at a Steiner school." But I went on fine to do get my qualifications to get into a technical university degree, no problem. So it was more of a plus for me. And I didn't go into creative and sort of arts field like many, probably more proportion of Steiner graduates do go into those like non-technical sort of fields and more creative. But I was, it's a bunch of us just do whatever inspired us. So yeah, there I was. Solar water heating got me into the whole idea of renewables being a good thing. So I decided I want to get into that as a career path. And then when it came to that sort of choosing a uni, choosing the courses, I tailored it for that and looked at environmental studies and then engineering. So I found a course at Lancaster Uni that combined both.
I want to stop you now because I want to spend a bit of time on that progression from secondary school onwards, and also to mention and ask you that your parents were obviously quite progressive, because Steiner schools back then, and you're a little bit younger than me, but you're still around the age. There wasn't that Steiner wasn't that well known back then, and for your parents to take that, I suppose, that risk, they must have been pretty worldly and progressive. Is that a correct assessment?
Yeah. I'd say both my parents are progressive in their way. So they're kind of, and their vocations sort of show that as well. My mother's been at humanitarian organisations really all the way through. She was in social work as well before that. And then my father's been in architecture, but also rural development. So empowering like people around the coastline of Pakistan from a kind of livelihood and environmental perspective as well. So yeah, they've both been quite inspiring people to me. And yeah, back in the day, I think my mum was really the driving. She did the research and found that the Steiner kind of approach had that holistic angle that was something that they valued and it was more of a novelty to my father. He was coming from Pakistan. He'd done his education and studies in the UK, but he'd not had that sort of exposure to more of those kind of options that the UK had on offer. So yeah, so I went into it and stayed.
So you obviously listened to your mum.
Yeah, well they did. Yeah. I guess they formed a kind of team approach and went with it. And like I said, later on, my father was a bit pleasantly surprised that I'd got as much of a technical aptitude out of my Steiner education as I did, because it wasn't all just about the creative non-technical, the maths, physics was very much part of it as well.
But it isn't, and I totally agree with you. I know a few people have put their kids through Steiner. We contemplated it at one stage. We didn't in the end. But what I did notice from the kids who went through Steiner, great problem solvers. Yeah. And isn't that really what we all need right now, the ability to critically think and to problem solve?
Yeah, I'd guess so, yeah. And to look at what the world is needing and then respond to that from looking on the outside as well as looking on the inside of ourselves, and how do we step up to what the world needs in today's context and what's coming tomorrow, and what sort of tomorrow do we want?
You mentioned that the first experiments you did was a parabolic water heater. There's been a few attempts at actually creating parabolic food cookers. Did you look into anything like that for like third world development, anything along those lines?
Yeah, I mean, my sort of academic interest spanned out to those cookers and so on.
Wow, yeah, right.
Yeah, but I actually got more into what was more locally scalable there in Scotland, which was due to the kind of low sunshine, it was the wind. So then I went into wind energy, and actually still at school, just on my last year of school, I found the old report. My father actually handed it to me back. He kept it all these years. I'd done this study on a local wind farm or the upcoming wind farms. So looking back at what I did when I was 18, I was actually quite impressed.
Wow.
Because I did this really thorough study on what the potential for renewables in Scotland was, what part wind energy was going to play. This is before the wind farms were all built in Scotland. So it was really ahead of the curve. And I went to a site that has been earmarked and permitted for a wind farm. I went and surveyed residents who lived near that to ask if they'd heard of it and what they thought about it.
You're 18.
18. Well, I did this graph and pie charts of my survey results. I was actually quite gobsmacked when I read it. I'd forgotten about it till I got this copy back in my hands. But that just showed that was in a crystal ball of what my whole career has been about. It's how to build climate solutions by empowering people with technology. So I mean, I love technology. I love, solving the climate challenge. And how do those two things go hand in hand? And I was doing that when I was 18 and putting this package together. I was actually a bit daunted by the advanced thinking that I had. Yeah, Steiner education.
That's amazing. and it's wonderful that your old man kept it.
Yeah.
That's crazy. So you're at high school, it seems like you already know what you want to do.
Yeah.
And, you would have spoken to a lot of people in your life. You've been around, I've been around. There's people who know what they want to do when they're 12, and the other people when they're 50, 60 are still going, I'm not sure. And most people fall in between. But it sounds like you knew what you wanted to do. So you went to, is it Landsborough University? Lancaster
Yeah.
University. What did you study there?
It was a combination of mechanical engineering and environmental science, and it was branded as environmental systems engineering. So it was a bit of a forward-looking group at that. I was looking for engineering departments that were kind of forward-looking into the environmental technology as a stepping stone straight to renewables. At the time, there wasn't any renewables-specific engineering undergraduates, so I had to pick an undergraduate that would get me to where I wanted to get to. So, yeah, it was good. I was in the environmental science department studying meteorology, the way the wind works around the planet. We touched on some of that in the course that I taught back when I moved here. I know you were one of the students at Swinburne.
Yeah, a bad one if I remember correctly.
But we don't know about that. Yeah, well, Wind Energy 1 as part of that Cert 4 in Renewables. So that was an opportunity for me to share a bit of knowledge about wind energy and the way the wind works around the planet. So I enjoyed that sort of study of what's purely natural about these energy sources that's not human induced, and then what technology we can bring to that to harness it directly without the fossil fuel problem and the sort of pollution burden and the unsustainability of that. It's going direct from nature's sources of energy, sun, wind, water, waves, straight to electricity that we can all use to power our lives. So Lancaster was good. It was a bit remote up in the hills there, good scenery, and I got through the 3 years there. It was mostly a stepping stone, I'd say. That undergrad, I found the undergrads it wasn't that challenging. It wasn't that kind of really that inspiring. It was more stock standard courses bolted together. They're all important, mechanics, power electronics, and some mathematics, and just I guess the building blocks of engineering, building and testing objects in the lab. I think I've got a wind energy dissertation, which was an analysis of extreme wind speeds and how they can be analysed so that you design your wind farm and your wind turbine to accommodate the long-term extremes of wind speed there. So that was interesting.
Are you still involved with wind nowadays? Enhar?
Yeah, Enhar is doing wind in the sense of prospecting for wind sites and engaging with landowners. So while the team and Trevor Ackland, I know you know well, a business partner there at Enhar, leads the commercial team, which is all the rooftop, behind the meter, solar, battery, electric vehicle work that is the bread and butter on that side of the scale of projects. Then I've been leading the team that's been broadening that out to larger scale projects, solar farms, battery farms.
Okay.
And then wind farms have come back into the picture through those skill sets. So we're out pioneering where the new sites can go. And so, we're going to windy hills and talking to landowners.
We'll get back to Enhar because I want to go into a little bit more detail about how Enhar came about and what you actually do, what you were doing and how that's progressed and what you're doing now. But back to the university, you finish your degree, you're going, I've learnt the basics. I got to ask, did you enjoy the maths side of things?
Well, I went on to do a master's in renewables where we did some of the aerodynamics maths, and that was actually quite fun the way it was presented. These
Bernoulli's equations,
monster equations that do have solutions. And I remember sort of memorising a few equations and the solutions and nailing them in an exam. So when it came to having a good reason to apply the maths, I did enjoy, wind turbine blades and optimising the amount of energy you get out of the wind. That's a good purpose, I'd say, for going that deep into maths. When it comes to just maths as a kind of as a fascination or or a kind of almost like a hobby. I didn't really take that up big time. But
it teaches you the discipline, though, doesn't it?
Yeah.
It teaches you because maths is about problem solving, and it's not about instant gratification either.
Yeah.
The higher maths.
Yeah.
And that's what I've noticed with quite a few engineers. They've said, I didn't necessarily like the maths, but it did teach me to, critically think and assess things in a methodical way.
I did notice when I was doing it that the lecturers were a few decades earlier than the students in terms of their adoption of computing technology. So this is already 20 something years ago, or maybe 30 years ago at uni. That's right. Yes. And it's an interesting topic actually is that gap of the uptake of new technology around computing, simulation, modeling, design. How software is just going exponential, but the adoption and use of it is a bit age dependent of the person that's teaching. So this is how. So it might be we getting handwritten notes with handwritten equations at uni, whereas it's a lot quicker and more accurate to use a computer-based approach. Not parking your critical thinking, but just using the available tools that have evolved, and then in the intervening time, it's even more so because it's just technology is just getting faster and faster. I'm not sure what you guys think about that. A lot of analytics going on here, and you sort of technical side of the industry.
I see personally. I'll take my green hat off and on. It doesn't probably on or off. I think it's a tool, and it's like a hammer. And if it's a good hammer and you use it effectively, all well and good. There seems to be potentially an over-reliance, especially on AI nowadays, in my opinion.
Yeah.
And I think the more that we personally rely on AI, the less probably our critical thinking skills will develop, and they may even retard. But that's probably a discussion for another podcast.
Yeah.
We could go into that pretty deep. But I think the tools are there. They're neither good nor bad. They need to be used effectively. But if they're not achieving the correct result, use something else.
Yeah, I mean, I got to say, back to your question about the maths at uni, I probably was pretty interested in how computational programs could make simplify and make more efficiency to get the answers that we were getting through the manual, more traditional methods. So I think that's a pretty important part of engineering is advancing the techniques, using the tools, the proven tool. But then it's a case of what's a proven tool.
Yes.
But I think you got to think critically about that. Like, it's a proven tool doesn't just mean it's been used by everybody for the last 10 years. It could be that 90% of people were using it later than they needed to. Like, I try to look at, I guess, glass half full with new technology. Probably you got to think about the half empty part and be equally cautious as you would be with any tool. But
I agree.
But I think I'm more of my personality type is more of a early adopter type. So, and hence, renewables as a big picture industry has been, early adopted over the last 30 years, and it's now at kind of 40% of total generation around the country. So it's like, it's not in the early stage, but it's still, people like myself were there 30 years earlier. So I think it's always going to be part of who I am, but just got to keep an eye on that critical thinking around what's a successfully proven tool that we can and should use, and what is it, if a tool's not proven yet, what does it need to prove in order to be proven, and then set that, give it a fair chance rather than just what's the word, like a fear-based approach.
That makes sense to me. I think one of the advantages of AI is that I don't think it's personally smarter than any human being. I just think, because maybe I have a different definition of intelligence, it just has the ability to do lots of tasks in a much shorter time, and thereby make connections. And what they're finding, say, with a lot of chemistry labs, and a lot of the experiments that are going on, they can actually do these experiments very, very quickly and gain the results, and then make extrapolate from there and come out with, oh wow, we've got a new compound for like a material science lab. We're going to be a compound that was always there, because all ideas are floating around, but it can just do it in a short amount of time. It's funny, but on the other hand, everything we do, including renewables and the adoption, is tempered by the economic reality of the climate we live in. That's a discussion for another podcast as well. Okay, I think we should. We'll come back to this, because it's really, this is what makes, I think, a lot of everything tick. So you're out of uni, your first job. What was your first job? Well,
like I said, it was actually during that master's. So I went from Lancaster to Loughborough Uni, did a 1-year renewable systems technology specific degree. So that was great. I really shout out to the Loughborough team. I hope they're still going strong. There were some great lecturers, the fellow students were all like real highly motivated people that were coming to really have a red hot go at the renewable sector from a technical perspective. There was some like entrepreneurial people that came in and founded their own businesses, like I went on to do. There was people that went right into academia and PhDs on solar and hydrogen, and the lecturers that came in were real sort of the authors of the books, the textbooks, and really the sort of some of the top thinkers in the UK at the time, and that was great. So I got a chance to do my dissertation embedded into a company called PowerCore. No coincidental same name as a company in Australia, but it was a power technology business that was associated with a coal generator. There's their Renewables sort of arm. So they were just starting in offshore wind, and they had their first couple of offshore wind monitoring masts out in the sea.
Off the coast of Scotland?
Off the coast of England, East Anglia. And so my dissertation was on analysing that wind data to see what the effect of the fluctuation of the tide height on wind speed would be, to see if there would be something different going on at sea when you had perhaps a long-term wind data source on land, and then your short-term was in the ocean with this influence of the tides.
Yeah, wow.
So it was a MATLAB journey, going into that computational process, that a lot of wind data recorded from these masts at different heights, and then they hadn't recorded the tide height, so we simulated that, sort of back simulated it using software, and it came out with a very minor correlation that the height of the sea did affect wind, very slightly.
What, the laminar flow of the wind?
The shear effect. So it was like it was an 8 meter maximum difference depending on time of year. I think maybe average of 4 meters per tide or something.
Is this the North Sea or
the North Sea?
The North Sea, that can get really rough.
Yeah. So anyway, published that and had someone in the industry tell me, thanks for doing that study, because it means that it's not really an effect that we need to worry about, because it was so small, but at least spotted it or quantified it. But actually, I'd done my first year of work during my undergrad. I'd taken a year out to go into industry, come back. So I went to what was called Garrod Hassan at the time, and Andrew Garrod was the founder of that kind of pioneering wind energy consultancy in the UK. Went on to become acquired by DNV GL, which is now major. Well, DNV was always massive, and so DNV GL, Germanischer Lloyd, I think, acquired it. Back in the day, it was a small group, a bit like this. You saw a small group, people in beavering away in a venue, right at the cutting edge, and the banks were all going to this mob for their due diligence reports before they would invest in wind farms. So they really got a good niche in the market. And Andrew Garrod was a bit of a author and a charismatic kind of. Strong on academic, strong on charisma, strong on business. So he did.
What a combo!
He did well, and so it was a good resume booster for me, and good people there. There was a lot of real boffins and PhD sort of people that was needed at the time. Wind energy, before a lot of the computational tools now, was just an absolute black box of statistics and data crunching that needed some really clever people to drive the tool. So a lot of spreadsheet gazing and looking into the matrix of what is the wind speed at this site.
Wow.
And I enjoyed that, and it was mostly desk-based work around those wind sites, getting the wind data and the wind modelling, the wind farm layout. And that's what I went on to. After I fully graduated, I went into Entech and started working there as a UK-wide environmental and engineering consultancy. So those two sort of strings to my bow. And joined the energy team there, the renewables team. We did wind farm projects, prospecting for sites, bit of wind analysis, wind farm layouts, and then the permitting. So getting the environmental studies together with the environmental team there.
Flora and fauna and stuff like that.
Yeah, flora and fauna and the various hydrology and all those. And we put together a few planning applications for wind farms. And so that was my kind of entry into the renewable energy sector proper. So having done that study I mentioned at school, like what is it going to take to build a wind farm? Then I was out there kind of amongst the industry and getting that consulting exposure. The systems of the bigger company, the quality management system was pretty helpful, and learning from the colleagues. We did a bit of wave energy work as well. That was pretty exciting. Scotland was or probably still is in some ways, sort of at that cutting edge of could we get wave energy to be a mainstream energy source.
The marine environment's so devastating to any material, though. That's the thing.
Yeah, I think it's a brave bunch that have really tried hard there, and with meanwhile wind and solar has just run away with from the pack. So the gap is very big to try and catch up with where wind and solar are now. And good luck to people that are trying other avenues to get energy in. But hats off to the wind and solar and now the battery industry around the world. I mean, it's just incredible.
We're going to talk a lot about battery energy storage, and we'll even talk about Flywheels if you want to, because that's, now, mentors like this Andrew guy. Was he a mentor to you?
I'd say he was probably an inspiring figure. There was other people at that company that were actually more hands-on with helping me out, and there was some lecturers that took a key interest in my interests. I mean, mentoring went right back to the school days. As I mentioned, Steiner School, you have that real sort of one-on-one mentoring on different subjects back there. But I'd say probably one of my mentors was my first manager in that Entech business there, Gavin Catto. So shout out to him. Don't know if he watches Australian podcasts, but I caught up with him in Scotland a few weeks ago.
Send him the link after this goes to air.
Some of my fellow graduates from Loughborough joined his company, and I actually worked in his business for a couple of times when I was coming back and forth from the UK to Australia. He's had that kind of that technical leadership, but also the people skills and that kind of client facing ability to know what people need to get their projects to the next level, and how to bring a group of clever people to the table to deliver that outcome for them. So that's kind of the model that I've followed in my career as well.
Because there's a lot of clever people needed, isn't it, for these?
Yeah, clever. I'd say clever and passionate.
Yeah, you can't. Yeah, you definitely need the passion and enthusiasm. It doesn't matter how clever you are if you don't have those, and the ability to organise those people is an incredible skill as well. Yeah,
to set a bit of a vision and then to communicate that in a way that makes people excited, and then let's make it happen.
Is that a learned skill, or do you think are some people more suitable for that? For managing people.
Well, I think
nature versus nurture.
Yeah, I think nature. I mean, in my experience, from my side, the nature is. I do have that nature of seeing a vision. Whether it's as a 14-year-old or as a 48-year-old now, it's like seeing where things, a good way for things to go, whether it's society, technology, or the world in general, and probably seeing a bit further over the horizon than other people tend to look. So. Seeing a good destination and then communicating that, I find that quite natural. When it comes to the people management, that's been more of a learnt skill, so that's more of a nurture and really understanding what it takes to have a good day-to-day process as well as a final destination. Enjoying the journey as well as the destination. Or in fact, maybe some sort of tell me it's more about the journey than the destination.
Well, time is our most valuable resource.
There you go. So,
we've got X amount of that.
Yeah.
That's really interesting. You say, and what about as an engineer?
Yeah.
Like, are engineers born or are they made? Like,
well,
I'm just going to leave it at that. Yes.
What would I say to that? I think it's both, like that inherent desire to make things work, but also that's kind of nature, and then the nurture is around the skills, which includes the toolkits to make things work.
But if you don't have the nature, the skills probably don't come as easy, do they? Like if you don't have I'll give you an example. Most of the engineers I've spoken to were problem solvers. A lot of them liked grabbing things when they were young and pulling them apart. Not necessarily putting them back together, but they want to know how things actually worked.
Yeah.
And to me, that's a nature thing. And then learning the skills necessary to become a good engineer is a nurture thing. But you still probably have that basis, that brain to go, oh, yeah, I want to learn those skills, and, yeah, I can understand that.
Yeah, I think it takes a fair bit of motivation to go through the discipline of learning the skills. And maybe some people got that more detail-orientated nature that just sort of gravitates towards that, breaking down the structures, building them back up from scratch. But I think you got to have a direction as well. So
yes.
So I mean, I've always been about the purpose of the enterprise and the career, trying to make a meaningful difference to the climate challenge.
Can you see it clearly in your head? Like when you say you got a vision,
yeah,
does it manifest itself as like images or what? How do you see?
I guess it's a picture of the future. A picture of the future in my case where we've got sufficient energy for what we want to do, what we need to do, what we have to do, and those energy sources are fully renewable, fully benign to the environment, and that we've got an atmospheric stabilization that actually brings back down the kind of alarm bells down, and the needle goes back down to, okay, we can perpetuate this into the long distance future. So yeah, it's more, I guess, it's a bit visual, a bit of a vision, and then it's like, well, okay, we know where we want to get to, or in my case, I think we have to get there. We have to get to a climate safe, sustainable future where we can have all the fun we want, but in a way that can keep going.
What's your timing like? Because again, I mentioned before, everything's tempered by the economic reality of the world. Suddenly feed-in tariffs go down, that changes the whole focus on how the whole putting energy into batteries or utilising energy whilst being produced by solar or wind, etc. What's your timing like? Because it's important to have a vision, but if you don't get the timing right, you're either too early or too late from an economic perspective. What's your timing like personally? Oh yeah, well, I mean, in broad terms, it's been pretty good. Like seeing the opportunity for renewables to be, and the necessity in my mind, it has to go that way. So it's a no-brainer.
It's a no-brainer. So again, driven by the kind of the global picture of what sort of future we want, and then talking to people who are in the businesses related to that can help to get in that direction. What do they see as the necessary skills to help it progress? I tend to be ahead of the curve. It's sort of part of my nature as well.
Early adopter.
Yeah, so while some things don't take off, many of them do, and batteries would be the next one that has now in Enhar, both at the commercial scale, major part of our projects, our studies and our designs and installations, and at the utility scale, large scale battery projects have become the largest area of our work. So and the growth in large scale battery project development is outstripped solar and wind by far in the last few years in Australia, and probably in other places around the world. So I was already into battery project development, 5-6 years ago at Enhar, and whatever it'll take to get to 100% renewables is really and what's the missing piece. So now I know, and I'll say this for the crowd as well, is that the reducing the cost of storage, so that the combination of solar and storage, to some extent wind and storage as well, but let's say solar batteries and wind batteries will become the cheapest dispatchable 24/7 source of power, and then we can just displace all the remaining coal generation in Australia pretty systematically and quite rapidly. So that tipping point of when large-scale battery technology, and probably in parallel to that, hybrid solar batteries behind the meter as well, become cheaper than what we've got now as a power source. Then it's that next big leap towards 100% renewables, because. And that shouldn't be relating to subsidies. You mentioned subsidies. I followed Australian federal politics, and I learned that just the less I've got to me and the business and really the sector has to do with the political football of it getting batted around it up and down, the better.
Absolutely.
So while make hay while the sun shines, if there's a nice grant and your clients and your business can take advantage of that, we do that as well, and we've done that in the past. But we used to do grant applications for clients when the grants came and went, but we've really softened off on that and just focus on the projects that we can repeat in whatever political weather that we've got. Now is a great time. We've got all levels of government in Australia all pushing forward on renewables, so that's nice, but it's not something to get addicted to, because it will swing the other way. And then we've got to be in the businesses that can handle the politicians trying to backtrack on all this good work, which is a feature of Australia. That, I mean, if there's listeners in other countries, you want to check out this politics. Federal politics in Australia is an absolute dog's breakfast.
No comment.
Yeah. So I try not to. Timing of I think politicians at best, they kind of lag the real necessary trend that businesses, grassroots people, consumers and businesses like ours and yours really lead the way, and then governments sometimes help and often hinder all of that.
The way I see it, and I'm not the owner of this business, I'm an employee, but I don't think it's incompatible. You can be ideologically sound and morally correct and sustainable and still actually make money. But a lot of people think that's not the case. At Greenwood, this is what we all think this is, especially the owner, Eddie. He understands intrinsically. And by the way, his timing is really good with stuff. He totally understands. And it's trying to get people who don't have that mindset into that way of thinking. You don't have to be a complete and utter bastard to actually do okay. Again, good conversation for another podcast.
Well, I think it's on point. It's like something I'm pretty proud of, is that I've kept my ethics and my vision around that building climate solutions all the way through, and what Enhar's achieved. Proud of the guys that and the women that have helped us on that journey, and that are still, really focused on making these projects work at a high quality. I mean, Enhar's been really strong. Trevor and the team, Dave Kincaid and the others, just being a kind of reference point for the industry around quality of projects, both on a design and procurement and commissioning operation. And these projects are not. It's important that they work really well. So that's also what we've been about, that sort of high attention on quality and that durability. And the education programs that Greenwood probably puts out is all part of that, helping people understand how to build things well.
We're going to get back to Enhar, but I sort of want to follow that chronological trail. So you're in Scotland, bugger all sun, lots of wind. What was your next job after the last job?
Well, that one I mentioned, so Entech was good. I wrapped up there and actually came on a bit of a career break to come to Australia and New Zealand. I was ready I'd worked pretty hard through uni and those initial years of the career, and I just said, okay, 6 months break, see the bit of the world, late 20s. And I took that wind in my sails and got myself to
literally
got myself to New Zealand, with Melbourne, where we are here today, being the kind of airport stop-off place, and got my backpacking in around New Zealand, had some great fun, and then came back to Melbourne, where I knew some people through my networks from Scotland, actually, and I got a job with the Garda Sands department in Melbourne, off the back of my UK experience, to sort of top up my bank balance, help out with a few wind farm projects, and carry on my travels. I got into I wanted to get some construction site experience for wind farms, so I wasn't just desk based and sort of greenfield. So I got a job at the Mount Miller wind farm with Power Corp, I think they were called, an EPC from Darwin, who are helping build a South Australian wind farm. So it was an Enercon wind turbine project there, I think 70 megawatts, Mount Miller, which was partway through construction. And I was an environmental and safety officer there for a little while. So that was really interesting, seeing how wind farms get built, and also getting small town experience in Australia. That was an eye opener.
Oh, wow!
I went up to Darwin, to their office up there, which was
a different world up there.
Yeah, that was fantastic.
Yeah.
It's more of a kind of a party town, so I enjoyed that. And then from there, I ended up going. I got this is all sort of short-term jobs while I was on a working holiday visa, which you can only have a short stint at each employer. So I went to Roaring Forties in Tasmania, Hobart, helped them out on some of their project management for the Studland Bay wind farms there that they were building. And they were the owner-operator, so it was a different perspective. That wasn't in the consulting end. It was more that, okay, we're spending our money to build these projects. We need to do that in a controlled way and risk manage that process. So that was quite an eye opener, and that was a good sort of learning curve. And then when it came to what's really next, I decided to start my own thing, and that became Enhar.
Hang on. So what about the Swinburne? What about the Swinburne? You'd already started Enhar.
That's right. Yeah.
Oh, I didn't realise that.
Yeah. So in parallel to starting Enhar as a new startup, as a consultancy, I did some teaching work there through one of the colleagues that I'd met at. I didn't mention I did a little stint at Acciona. Again, these are short stints.
I remember you mentioned that while you were lecturing that you were at Acciona.
Yeah, the Warburg wind farm and a few other bits around the quality management system for the company. So that was interesting as well. Again, how they're building the Warburg site. And one of my contacts there introduced me to the idea of teaching at Swinburne, which is also how I got to meet yourself and all the other students back in the days. And that was a good opportunity to share some knowledge and support people learning. I mean, I love learning, and I was able to sort of share that passion for learning. I know
I've still got my wind notes.
There you go.
I've kept all those notes from those days.
Yeah.
Wow, that's I didn't. So you'd already started Enhar. I didn't realise. Wow. Yeah.
Yeah. So I was early days knocking on doors of clients and offering support. Some local councils took us up with client services, and some of the developers looking at early stage wind farm projects as well. But then rooftop solar became a key area, and we got some repeat work in that sort of space, doing feasibility studies for local councils around Victoria. So yeah, a lot of respect for the sustainability teams at local councils. Are still to this day, and I'm sure will continue, long into the future, have that similar. It's like, how can we make our organisation, our local council, more sustainable, more clean energy, lower emissions, and we've done X, Y, Z already. What can we do next? That's gonna, because it's this ongoing journey, and so the sustainability teams are really on the same page. And I was fortunate to form some good links there and provide services, which is still one of Enhar's key client bases.
That's great.
Yeah, local governments who are still, I'm sure they will continue to be that. They're sort of leadership. They're our early adopters as well. They bring in, solar, batteries, electric vehicles, and other, efficiency solutions, so that the council-owned buildings can be, exemplars for their
lead by example. Yeah, exactly.
Yeah, and so they're able and willing to invest a bit in that as well, and to be those sort of showcases once the payback has to be there, but not as strictly as it would be
as a commercial situation. Yes,
yeah. And so by the time commercials are adopting it, the costs have come down as well. So it's a really good process.
How important is it in your mind building relationships with these, I suppose it's a public service, effectively. It's a council, and also in general with business. I mean, it's a very broad question.
Well, for us, it's been absolutely instrumental. Like those, good thing with councils is that they share their knowledge between each other for the mutual benefit. So we might do a project with one council, and then there's a pretty open source, showcasing of that project to other councils, and the referrals come in through that as well. I mean, there's always procurement and competitive tendering needed, which we respect, and we've been able to be a trusted partner for heaps of local governments, also in New South Wales and a few in Western Australia, as well as a lot in Victoria. So and then educational institutes are similar, leading by example. So universities have been a big client base, and Enhar's done some great work for Melbourne Uni and other La Trobe and others. Trevor and the team continue to provide that, that quality management. Helping
the agrivoltaics set up at Dookie. It's fantastic.
Yeah, that campus of Melbourne Uni up in regional Victoria. Yeah, that's a good one. Yeah, we did monitored wind speed on a hill near.
Well, we know all about it because we put it. Well, we installed it. So
okay.
And I went out there and spoke a few times with Sabine and her cohorts out there because it's over a vineyard.
Yeah.
Look, that's
100 kilowatt system.
No, it's much smaller. That was it's only I think it's 25, and another 16 that's a separate. That's not on top of the vineyards. Screw piles, very sensitive. Obviously, being aware of the root structure of the existing 15-year-old vines.
Yeah. I was talking to a landowner yesterday about agrivoltaics. Actually, looking for an angle to put on his solar farm opportunity in northern Victoria. So
interesting. I mean, to me, obviously, it's that order of priority. It's air, water, food, then energy. And if you can combine, food or wine and energy, that's a no-brainer. I've done a few things on agrivoltaics. It's a personal passion of mine. It's just why would you put in a farm? Especially you don't want to be displacing viable agricultural land in any way, shape or form, just purely with a solar farm. So, and we'll talk about that a bit later on. We've got a lot to talk about. Now, you've started off, you've got Enhar, you've built up this customer base, you've got some councils, you've got some universities, and then you've got obviously some private businesses as well.
Yeah.
So tell us, how things, you've been going now at Enhar for, it must be
2007. I founded it. Trevor joined me in 2011. So it's been 14 years under that sort of.
That's a long time on renewables, isn't it?
Yeah, a lot happens in that time. Yeah.
And how have your processes changed over the years? Do you still approach things in the same way? And I'm not talking about the nitty gritty. Obviously things are changing, but the overall vision, has that changed at all?
Well, I think the purpose is still there. It's to raise the quality or raise the standard of the solar and smart energy industry through that excellence in engineering and quality management. So that's really been the mission statement for Enhar, and continues to be. Well, as I mentioned earlier, I've looking for the bigger impact opportunities while the commercial business continues to provide that service for those projects like the university campuses, local councils and corporates. And there are, some players like Reese that are using Enhar for their rooftop solar rollout, which is fantastic, across retail and wholesale stores around the country. What string that we've added to the bow is these larger scale project services. So a bit like Greenwood, you've got the utility scale project string to the bow as well, where those beyond what you can fit in the urban areas, you go into the regional and you can fit these bigger projects with solar farms. So in terms of how we've evolved our approach, I guess if I could talk about that side, it's
for sure.
providing site identification services to developers that are looking to build their portfolios of solar farms, wind farms, and battery projects.
What does that actually mean? The site.
Well, we do.
You make a site assessment.
GIS mapping across huge areas of the country, narrow it right down to those sites that meet the suitability criteria. Grid proximity, unconstrained from environmental overlays, enough distance to offset amenity concerns to all residential, and vehicle access. There's a whole logo into the mix. If it's wind farms, you got more because you got to be away from airports and coastlines for sort of cyclonic risk factors. But when it comes to say batteries, we're out there talking to. Then we talk to landowners. So we strike the agreements with the landowners, form those relationships, build a trust.
Are these PPA kind of agreements, or what are
Well,
they?
that land agreements are usually an option to lease the land. So once the permits are in place, then a lease will kick in, and the landowner will get a long-term rental income. So that's a good match for landowners that have land that there isn't prime or is a minor enough portion that it's a win-win for them to.
So they get a steady income flow.
Yeah.
Which is something they're probably not used to because they're farming the land.
Yeah.
They've got sheep or they've got whatever, and they're at the behest of Mother Nature. But you're going in there and saying, well, we want a parcel of your land and you're going to get this adjusted to the CPI or whatever year after year after year for 20, 25 years or whatever.
Yeah, or longer.
Wow.
Yeah.
They must love it.
When the fit's good and the trust is there, some landowners are open to conversations, or you've got an interest in doing something on my land that I haven't done to date, so let's hear you out.
Yep.
And if they if you present a clear honest case of what it is that you're going to be doing and what it will mean for them and how much air it will take, what equipment will be there, then we've been very successful in building that trust and striking those agreements. Sometimes we strike them for us on our behalf, and then we make that available to developers who will take it to the build and operation stage.
Well, you on-sell it?
Yeah, or partner. Provide a service that, we're providing we're basically taking the stake in the ground ourselves and going out there, do that initial origination, and then we're talking to the developers that have an appetite for increasing their portfolio and say, well, we've got this site, we've got a strong relationship with the landowner already, perhaps something is in writing. Or in other cases, the developer says, right, this is our kind of remit, we want sites of this size in these regions, and then our team, who are super skilled now, I've got to say, shout out to the team, do the mapping I mentioned. It's incredible what can be done on GIS, geographic information systems now. And then those skill sets to go out and phone call, drive out, meet in person, form those relationships and come to an arrangement that suits the landowner and the developer. And then from then we're also helping go to the next step, which is the permitting side, so the development approvals and putting the package of studies together. We've done that mostly. The largest number we've done is in South Australia. There's quite a it's been a really good opportunity in South Australia and we've had 4 permitted there and another one in progress. Victoria, we've done a couple. New South Wales, a few in progress.
What kind of battery size are we talking about?
Well, Victoria was the smallest one we did, 4.9 megawatts. As you know, that's a. Yep.
Yeah, so with the landowner engagement, you're talking about permits. You're also talking about entering into relationships with the landowner themselves, being a stakeholder, and also other bodies as well. Other people who may want to invest in this. Is that the way? Have I got that right?
Yeah. It's the relationship with the landowners and the permitting authorities, and getting what they need lined up to be able to evaluate and approve the projects, and then relationships with the project developers that are going to build and own these assets, and that they're our ultimate clients. So it's been good forming those relationships with all 3 of those, and look forward to doing a lot more of that. And it's about the battery projects are probably the biggest growth area. We're doing some wind as well. we're doing a bit in solar, and then transmission lines will be the
Really?
Another. Well,
is that where you're looking?
That's where we're looking. In terms of what's next, always looking at what's needed next, and sometimes particularly wind and solar projects are being prospected a bit further from, particularly wind, further from the existing transmission. So you need to engage and find agreements with landowners in the in between. And there's a lot in the media about the challenges with bringing the community on board with new transmission lines around Victoria and around the country. So it's a hot topic, and it's essential for connecting the resource to the loads.
I can see the logic. You create it, store it, transmit it.
Yeah.
So I throw that one in.
Yeah, pretty much.
Yeah, it's with the battery stuff, the energy storage. I'll say energy storage because when people hear batteries, they generally think of chemical-based batteries, but there are other options out there, and we'll talk about that a bit. What size are we talking about? It's pretty considerable. What kind of megawatt? Are we talking megawatt hour, 10, 20, 30 more?
So some of the sites we're working on are at the 100 megawatt scale. There's a relatively small parcels of land, but electrically you can fit a lot more in as the equipment's getting a lot more compact, and energy density is really accelerating. So that's pretty exciting because you can do so much more with the same small amount of land. But also, like 500 megawatt batteries are in demand, so we're talking to developers about that as well. And this is about that early stage site identification, land, securing the lands, and getting the permits. We do the concept designs as well, so we've got electrical engineers in house and 3D and 2D modelers that can really visualize the project, so you can show the neighbors or investors this is what we're going to be building as a simulation. We take our drone out and get that aerial footage and the topography, so we've got that kind of survey capability to really get the project up and running, get the ball rolling is the idea, and then we'll probably because they're such big projects, there's a lot more to do in the life cycle of the project, but we're really focusing on those early stage skill sets to get the project from I guess the concept through to serious development progressing.
Are they mostly FCAS or Arbitrage, or is it an equal split with these battery systems?
Yeah, well, the frequency control market, the FCAS, is the sort of diminishing proportion of revenues for batteries. You can see that in conference presentations pretty clearly. And then the arbitrage income is the increasing proportion, is the strongest part of the revenue stack for batteries moving forward. So there's a lot of batteries coming in under construction. There's a lot in the pipeline. So there's probably an abundance of projects for there's only a limited grid in Australia.
Yes,
I mean there is going to be increasing demand of some kinds, electric vehicles, maybe data centers as well.
Yeah, of course.
Yeah, so that's pretty important how to get those powered with renewables and storage, and from a environmental and climate perspective. So but big it's getting bigger and bigger. Like project economics, once you get to these large scales, are favourable when you go as big as you can.
Yeah, economies of scale.
Yeah. I mean, developers do have their investment sort of limits. Like they're not all able to invest in a 500 megawatt battery.
Wow. Yes.
So we do get kind of tailor our approach to what each client is, their investment kind of magnitude is. But because of the timeframes in these, often the clients increase their they might want 100 megawatt projects sort of today, but in the future, not too distant, they'll want it 300-400 megawatt, because economies of scale become more attractive to them over time.
And that determines the design of the battery that you use.
Well, the selection of the voltage that you'd be prospecting on, the higher voltages would be suit the higher capacities, and then also the amount of land that you're targeting. Bigger projects need that much more. So you've got to be thinking ahead in these multi-year sort of development cycles, and then long duration is going to be is increasing to come in. The average battery that's going in is sort of more than 3 hours duration now. It used to be sort of 2 hours. Well, they might have even reached the 4 hour kind of average mark now. So that's, as I mentioned earlier, the breakthrough that is kind of exciting to look forward to is when longer duration, 8 hours plus 10, 12 and longer become economic on the battery side. Then you can have a solar and battery plant that can dispatch through the night. And I mean, that's when the economics of that are again hit the certain point. And it's trending in that direction.
Yep.
Because coal, cost of generating coal at night isn't going down. So you've got that sort of
nor gas
fixed target to beat, and it will happen. So
it'd be nice if solar panels had progressed from efficiency perspective as well as batteries have from an energy density perspective.
Right.
I mean, when I started solar was, I think 13, 14%, maybe 15 on the really good ones. And now the best is, 24, 25.
Yeah.
But batteries, going from a flooded lead acid basis, deep cycle, to a thixotropic gel-based battery, to now even lithium iron phosphate improving energy density, even within that safe chemistry, let alone all the other lithium solutions. Prices come down radically. Throw in a few supercapacitors, hopefully, and we'll see some pretty crazy stuff. On that note, do you think that there's a possibility that when batteries from a domestic perspective get really, really cheap, that a certain percentage of the population in the right area may completely go off grid? And I'm talking domestic. I know that's not what Enhar does, but I just wanted your personal view. Do you see that happening? Or is that security something that people will always crave, and therefore they probably won't go off grid unless there's no other option?
I think there'll be niches that would be candidates for that. New retirement villages getting built out beyond the fringe suburbs now that are facing quite large grid connection costs.
Yes.
At some point, it will become economic for them to be an island, but probably not there.
One block, but no house, just a big ass battery, for want of a better expression. Maybe some solar, and then solar on every one of the houses, and it's like a satellite kind of setup.
Yeah, I mean, like we've had for a long time, those off-grid residences or even residential clusters like Murra, who's sort of quite far out from the existing grid. The economics have been favourable, but in terms of urban residential reaching that tipping point, because the infrastructure is already there for grid connection, they probably get the benefit of being able to export, maybe provide services like the managed services where your home battery is generating a bit of extra income by being grid connected.
Virtual power plants, that scenario. Yeah. So
then everybody gets to benefit from that.
Good point. It's interesting to see this progression of the batteries. It's fascinating to me, and I know with the holy grail of FCAS and probably to a less extent Arbitrage is response times with these batteries. How quickly can they dispatch energy? How much energy they can dispatch, and for how long? Must be some pretty interesting algorithms, predictive and otherwise, that go into all of this. Do you have any sort of experience with that side of things?
Well, Enhar's got NSIM, which is an in-house simulation tool that we've developed, and Andrew Redaway has been sort of leading on that side of thing. Andrew was the brains behind Sunulator.
Right, that's what I heard his name.
Yeah. So he's been working with us for several years.
Wow.
It's been great having him on. So he's can do a really advanced sophisticated modelling using Excel. So that's our in-house tool. So there, the battery.
Wow, Excel.
Yeah, Visual Basic and Excel can really do a lot. So
it can't it?
Yeah,
I do know.
So the ways to simulate battery behaviour to benefit the client's kind of return on investment has been something that we've been doing for for a long time, as I know others have. So it's interesting to see. I mean, the FCAS, frequency market revenue for distributed batteries is sort of harder to count on. Is still more kind of, I guess, systematization of that needed, or kind of standardization maybe, because it's not just off the shelf. But it's things are trending that way. Vehicle to grid battery enablement is something that we're sort of conscious of as we work with clients on their electric vehicle charging infrastructure. Again, we're doing those sort of council fleets and commercial scale, not the residential. Although we do work for some residential developers who have those large, several hundred houses in a project. But then at the large scale, it's pretty exciting to see batteries doing really well commercially, and there's so much more coming in. And even the duck curve during the day when power prices are dipping or even going negative because there's so much surplus solar, both large scale and small residential scale solar flooding in, that as batteries become more I guess abundant in terms of both large scale and distributed, but let's say large scale, able to buy those that cheap power or benefit from that dip in the dark, it's going to gradually lift that, so the power prices will sort of recover in the middle of the day thanks to batteries. So that's really exciting.
That's very interesting.
Yeah. So solar will then be getting more value, which as it should do, because as batteries can spread the benefits of solar to more hours in the day, solar, it becomes more of a key player, not just because solar farms are really dried up as a business case at the moment, but this will make them come back.
You mean, are you envisaging, and you're probably already seeing it, that the existing solar farms are going to now augment with storage? Yeah, because that's a logical thing.
Yeah, retrofit. Yeah. But even the standalone batteries that are sitting around the transmission grid,
without any solar at all. Yeah,
our customers for that.
It's quite weird, isn't it? Because at the end of the day, batteries are dumb devices. The only time they produce energy is when you buy them brand spanking new. After that, they are simply there to facilitate the exchange from the input going out to the grid. And I always try to, with a loss, by the way. So I think, it's a funny one if you think of it from that perspective.
Yeah. Well, it's
because that's what it is.
They're just they're shuffling energy from time A to time B, but they can do it in such a responsive way that it's actually bringing down prices for stabilizing the grid through batteries is cheaper than it was doing it through just through hydro, coal, and gas and demand control, which was before the big battery in South Australia was switched on a few years back. That's how the consumer was paying for stabilizing frequency, but now it's batteries can do it cheaper and faster.
Yeah, it's amazing what they're doing now. Again, I know. Hey, I'm saying like I'm hitting the replay button, tempered by the economic reality of what's going on in here and now. But what's going to happen though, because we have to transition away from coal and gas, but we've got this huge non-linear increase in EVs, and let's face it, EVs haven't taken off as quickly in Australia as they thought. A lot of people have got hybrid vehicles. Case in point, my wife, son smashed his car, so we gave him our old car and we bought a hybrid. We were going to do an EV, but we bought a hybrid, right?
Okay.
We did a cost-benefit thing.
Yeah.
So a lot of people have gone down that track and they're getting a transition vehicle. But once the EV tech becomes fully mature, everyone's just going to go whoosh, and it's just going to go like that, and suddenly you're going to have these massive loads. Throw in the extra AI data centres, and the effect on the grid is going to be huge. So we'll need a lot more renewables and a lot more batteries to stabilise all this and provide.
Yeah, interesting.
So it's going to be we're living in interesting times, aren't we?
Yeah.
And we're in an interesting industry as well. I want to talk about Flywheels a little bit, and is it something that you know a little bit about from an energy storage perspective?
Look, it's been on the sort of academic interest radar, and I am interested in storage that can reduce costs beyond what the chemical based batteries are delivering. But no, I haven't been directly involved in like commercial projects, really getting into nitty gritty. What's your view on?
Well, I think I've got a friend who's involved with them, and I had him on the podcast, and he deals with a American company, and they're making them currently in South Australia, Amber Kinetics. So you're talking about rare earth magnets, maglev effective technology, 5 or 10 ton of a large lump of steel spinning with a vertical disc. Coming in ranges of, I think, increments of 100 kilowatt hours up, but their response time is absolutely phenomenal. They have no degradation, and that's the thing. Compared to a chemical battery, you've got this degrading. Like every time you turn a light switch on, we know it gets a little less bright, and every time you use it, discharge and charge a battery, it gets a little less capacity. And a lot of batteries have a warranty of X amount of cycles or a 10-year period. Flywheels don't. They can be discharged every day, all day, down to 100% and be charged up with no actual loss in capacity because they're a mechanical battery. Obviously, the inverter component has to be changed out in 10 years if you're doing your modelling. But these things will last 25 or 30 years, and they are really totally not susceptible to very cold temperatures and very hot temperatures. And above all, they're safe. Because one thing people are looking at is in all these high-rise buildings, right, putting in a large energy storage component in the basement to trade or to provide UPS power to the building or to do an FCAS, what have you. But people are very wary of the chemical battery side of things. So if you start putting these flywheels in, you're really reducing that safety concern. Yeah. And with the flywheels themselves, the earlier ones had to be buried or contained. But once you start reducing their RPM, and you can sort of dial them down a bit, then they don't have to be contained. And I really see them being... I'm waiting for Greenwood to do a project. We missed out on one, but I'm dying to get involved in one where there's a chemical battery and a flywheel battery, and you get the best of both worlds combined, maybe with a floating solar array and some solar. And my gosh, that'd be an interesting project. I really see it from a safety perspective, and also in areas of high temp like Northern Australia, mining centres. They're going to come. The only problem is that they don't seem to be advertising very well. And we know flywheel technology has been around for 50, 60 plus years. But Amber Kinetics, maybe have a look at them because, it's going to come. And what do you think about... But they're too expensive.
Yeah.
That's the thing. Yeah. That's what's holding them back.
Yeah, it's probably ARENA projects sort of trying to bring that cost down. What do you think about the non-flammable chemical batteries?
In the sodium-ion batteries.
For example.
Yeah, I spoke to Gareth Thomas from DPA on these. I noticed they were at All Energies. I think safety is a really big concern, not only for the general population, but also emergency services, anyone, firemen, what have you. The safer you can get that energy storage, the better. The problem is it has to also be energy dense enough, or it comes down to cost. And also the space it takes up. And they're not as energy dense as lithium iron phosphate, but gosh, they sound bloody safe. I'm pretty excited about them. But we'll see. Yeah. Because unless they, tick a certain amount of boxes, they won't be commercially viable, like anything else in this world.
Yeah. It's got to. That's the thing. To really break through, it's got to tick all the boxes.
It's got to tick all the boxes. Yeah. And at the moment, lithium iron phosphate's ticking nearly all those boxes perfectly well. Apart from, the safety, they're the safest, but they're still a chemical battery compared to, say, a mechanical battery that doesn't have that issue. And by the way, is totally recyclable. So that's so there's a lot to think about. I want to talk about Treecoin, which I assume it's a cryptocurrency. Is that right?
Yeah, it's a digital token that helps.
And you started it.
Yeah, so that's
Wow.
another one I founded a few years back, along with a co-founder who was a good thinker around economics and what about a carbon-backed currency for our economy moving forward. So the mission there, same, to build climate solutions by empowering people with technology. So the technology is Treecoin is this end-to-end platform where you can create the tokens from a forest, you can store, transact or retire them as a carbon offset, and then in the future it'll be able to be exchanged as a merchant point of sale for goods and services. We're in the first phase, which is the carbon retirement token utility. So if someone's, Enhar's used them as a Treecoin as a way to offset our carbon footprint as a company. We were also Climate Active certified, which was the Australian government kind of scheme for voluntary companies that want to also certify that they're carbon neutral. But what we found was with Treecoin, Enhar could be actually offsetting more, so supporting more forest growth at a lower cost, because the auditing cost of Climate Active and the third party overhead to get that to maintain that certification is actually about 80% of the annual cost. Only less than 20% goes into actually buying the certificates.
Right.
So with Treecoin, trying to flip that round, where most of majority of what you're spending is on the tokens themselves. So you could even double the amount of tokens that you buy, and then self print off your certificate in the Treecoin portal.
Right.
Got a t-shirt here. So then you end up with that evidence trail of okay, we bought the Treecoin from this forest, we've retired it on the blockchain here, and there's the evidence that we've addressed our carbon footprint for that period. So it's the same outcome, but it's just a smarter way to do it. And looking at the carbon credit market, looking at the climate situation, we think if we could massively scale up the carbon credit incentive to reforest huge portions of our country and around the world that have been deforested, you're looking at a major climate solution. Like it's obvious that forests store carbon, but what's not obvious is how we incentivize and guarantee that they will be restored and maintained. So we need economics to drive that. On a certain scale, bigger than what government, conservation status here or there is important, but is limited. So Treecoin's about democratizing and decentralizing the carbon market. Yeah, so it's an app it's a software. People, if you've got a bit of land, I know you've got a bit of land, so you can create an account, and then you draw a map around the spot part of the land that you want to allocate into earning Treecoin. So if it's got trees now, or it will have more trees in the future, then that's a good site to use. And the satellite record also goes back. So if you've got if you've been maybe curating that land for X number of years and haven't had any carbon revenue for that, but the forest has been under your management, has grown, then the satellite record also credits that historic component of growth as well.
Is it species specific?
It's satellite uses the radar and LiDAR kind of functionality to look at the canopy surface. Right. And then these things called allometric equations, which attribute estimates based on scientific studies around that similar geography to the amount of carbon that's in that forest, and also apportioning to what's in the soil as a direct result of that forest. So satellite tech is pretty impressive now. It's also ubiquitous, so it's around the planet. It's constantly refreshing its imagery. So and that we've got an integration with a platform that does that sort of behind the scenes. So you'll get a report out that shows that carbon history from that satellite data.
Yeah, wow, that's really interesting. I never, yeah. You have to send me a link to this, actually.
Yeah, app.treecoin.global will get you there.
App.treecoin.
And I'll send you a link as well.
No, please,
yeah. Because
No, send me a link, please.
Yeah,
No, it'd be very interesting.
Yeah.
So what about the whole ESG side of thing and, project, scope 1, 2 and 3? Is that something that Enhar, records and that sort of thing?
Yeah, well...
Because I know that's...
On the...
Yeah, at this point in time, a lot of the councils are going through this. It's one of the things that my wife does.
Yeah.
And I'm trying to get my head around the difference between scope 1 and 2 and 3 and how it all, and it's a lot of confusion and this, that and the other. But it seems to be the way that it's all going.
Yeah.
Is Enhar ahead of the curve in regards?
Look, we're focusing on the energy and mostly the electricity side of reporting. So what's going on the the annual footprint of an organisation or a council or a university or corporate. So when it comes to those sort of broader emission scope from transport and indirect, probably clients would go to other platforms or service providers. I've got to say that it needs to be more automated as well, because what we don't want is these big barriers to be able to evaluate, report, and then offset. We want it really to be a lot more automated and a lot quicker, cheaper, simpler, so that people can do it sort of...
There's a lot of confusion in this area.
Yeah.
A lot.
So I think what will emerge there is much more automation and smart tools that are very trustworthy, but they're just much easier to use. So... if you look at Xero and other accounting softwares, how much easier, quicker, simpler, cheaper that's made financial reporting, the same will happen in carbon reporting.
Yeah.
It's sort of, we're nudging in that direction. But no, neither Enhar nor Treecoin is like filling that particular niche. But once clients have got their carbon data, then they can log on to Treecoin and offset their emissions. You can pick forests that are in Australia or other countries, depending on how they think they would best like to offset their carbon. So we've got Treecoin's got projects, forest projects in Australia, Indonesia, a few African countries, Zambia and Kenya, and a few European countries. Just projects popping up, and we've got European partner who's helping us expand in Europe and the Americas as well.
Wow!
So yeah, it's interesting, balancing the my time across two businesses and a lot of
juggling,
a lot of good support, and sort of careful scheduling around when each one is like taking my full focus. But with good business partners and good team, across the board, it has been a good process to contribute to both the continued decarbonisation of the energy sector. That's what Enhar is all about. Energy in harmony. That's where the name comes from. So. There you go. Yeah.
It's so obvious when you say it.
So harmony with the natural systems. We're not depleting. We're kind of keeping everything renewable, and that's the decarbonising of the energy sector. And the energy is now broadened out to transport. So Enhar is in the electric vehicle infrastructure kind of space as well, which is exciting. But Veli, like climate and the carbon balance in the atmosphere, it's a bit like someone who's smoked for a long time. You got to reduce smoking, ideally give it up completely. But then you've also got to recover what's already impacted for X number of years.
Yes.
So same with the atmosphere. We've got to draw down and actually reduce the amount of atmospheric greenhouse gases that are already kind of forming this blanket that will have this ongoing long-term thermal effect. So two-pronged approach. It's all part of that kind of climate vision.
It's funny, and again, I'm going to take my Greenwood hat off again. When I studied all of this, and way back when, and I've helped build a straw bale house in the mid-90s, and I have an interest in gardening, permaculture, biodynamics, all of that stuff. And back then, we were all talking about reducing our footprint, treading more lightly. But no one talks about that anymore. No one talks about reducing their consumption for the simple fact that you don't make money out of it. So for me, it's very frustrating when, yes, hey, I'm involved in renewable energy and solar and wind and batteries. It's a no-brainer. But then I see, the average consumption of an Australian house going up and up and up because in conjunction with appliances that are more efficient, that people are just using more. They're just using more. And it's ridiculous because I look at what my parents used and if they looked at what their grandparents used and I equated it to the level of their happiness, my gosh, they were happy when they were using less, So it's hard for me.
Yeah.
It's hard for me, yes.
I think...
you know what I'm saying?
Yeah, I think you could there's an uphill sort of battle in that sense. But I think what we're doing in our industry, the clean energy as well as the carbon drawdown industries is charting a course for the right sort of future where we can continue to power and support the lifestyles that people, consumers, everyday people will continue to want. It's only a minority of people that will ever be making a professional focus or even a personal focus on sustainability. So within that kind of micro sphere, you've got a kind of captive audience of people that will adopt. But our real job is to make the solutions that the broad masses will adopt because they're cheaper and better.
Yes.
And so renewables, again, hats off, like it is making power prices cheaper. That's a consequence of renewable energy uptake. So fantastic. And everyone wants a cheaper electricity bill. They may then use more.
Absolutely.
But at least they've joined the party. They're not needing to be persuaded of some, sustainability agenda that they may or may not have in their own priorities.
No, good point.
And the same with carbon drawdown. It's I do with Treecoin is to make it the economics swing towards just reforestation being a lucrative pathway.
Not only the right thing to do, but the right thing to do financially. Yeah. I totally understand.
And when those two things come together, then you do see mass uptake, and that's what's really exciting. That's what's always excited me. So I'm still all about that, making it a win-win, and the more people that adopt, let's say clean tech, who didn't come at it from a sustainability background, that's the biggest success of all.
On that note, we could talk, as in the break we mentioned, we could talk for a lot longer. There's a lot of stuff we haven't covered, but I think maybe that'll be for podcast number 2.
All right.
Because I definitely want you to come back.
Okay.
Thanks for coming in. Really appreciate it. And good to see you after all this time as well. So
thanks for the invite. No, it's an honour to be on, and thanks for the audience. So I hope this is useful for people listening in.
It will be. Thanks, Demian.
Thanks.
Cheers.
Okay.